screen now?
Yeah.
Great. So that's the first graph. And the very first thing it asks for is the domain. So the domain for this one is minus infinity to infinity because it's smooth. There's no vertical asymptotes. There's no holes. There's nothing like that. The range is also the same, minus infinity to infinity.
Got it.
Now the next one here is continuity. It's continuous everywhere. So minus infinity to infinity. You can draw it everywhere without lifting up your pencil.
Yeah.
All right. Next thing here is it says increasing, decreasing. So we'll do increasing first. Increasing is when it's going up and to the right, kind of that direction. So it is increasing, and these are on the x values, minus infinity to, and I guess your instructor's okay with this. We'll just use decimals to this point right here. So see how this is going up and to the right here.
Mm-hmm.
And then similarly here, it's also going up and to the right. And it's the x value, so it's increasing from 0 to infinity. So it's not the y value. It's at this x position. It's going up, and often these are confused or misused here. Okay, decreasing. Decreasing is when it's going down and to the right, down and to the right. Okay.
Mm-hmm.
So it's decreasing in this interval here. So from minus 3.33 to 0, it's decreasing.
Got it.
Bounds. I don't really know what your instructor means by bounds. Any idea what he's referring to there?
I think it's like the ceiling and floor thing, but
Okay, so this
this
does not
one,
have one. This is
yeah, it doesn't have bounds.
this one's unbounded, is what I was going to tell you without knowing what, you know. Okay. So then Extrema. So minimum, maximum. This one, it has like what's called local extrema, which is this max and this min, but it
Mhm.
doesn't have absolute max and absolute mins. So do you have any idea on that?
Um,
So
so
like,
you just put the points for
so,
the
well,
local?
it's called a local max. It's not the absolute max. The absolute max, there is no one. There is not
Yeah.
one because it goes all the way up. Yeah, it is. It is that point. And then there's a local min, which is 0, comma minus 2.
Okay. So local is just if there's like the points and then
Yeah, it's like let's say you climbed the top of some hill here and
yeah.
you feel really good about yourself, and then you get over it and you realize like, oh, I gotta go all the way up. Like you feel
Uh-huh.
good locally, like locally you're there, but globally you're not all the way
So
there.
what would a global max look like?
Think of a parabola.
Oh, okay. So then the top, the vertex
Yes,
of it is
yes.
the
And
global.
this is now bounded. You know, that's one of the, I
Uh-huh.
mean, that's, some of these go together. Symmetry. So symmetry, this one doesn't have any, so none.
Mhm.
Um,
Okay. And so if there was symmetry, how would it be asked? Like, would you say like vertical or horizontal? Like,
Yes,
that
yeah.
kind
Like,
of
well,
thing?
there's even and odd symmetry.
Uh-huh.
Uh, this one doesn't have it, so not sure. Like, we'll see it. I think we'll see it in one of them, but this one doesn't have it.
Yeah.
So part of this is like not everything has it. Like this one doesn't have any vertical or horizontal asymptotes.
Hmm.
So let's see here. Vertical asymptote, none. Horizontal asymptote, none. It does have end behavior. So I like to write it like this way: as x goes to infinity, as x goes to minus infinity. So now we go back up to our graph. So as x goes to infinity, so that means as you go to the right, how high up does this go? It goes up forever.
to positive infinity.
Yeah, so you can say f of x, and this is really your y. Y also goes to infinity.
Okay.
And in the other direction, if you go back up to the graph here, in the other direction, it goes to negative infinity.
Got it.
Okay, so that's the first one, and we're going to repeat that for the next one. I can, so I'm going to snip in a graph. I also probably should just snip in the thing to fill in so that it's a little bit clearer
Okay.
here in case I don't, a lot of things can happen. All right. All right, so we're gonna graph this next one. Oh, and you have to put a graph at the bottom, so hopefully you're making a rough sketch, or you'll use the notes, which
Yeah.
try and get to you right away after we're done. All right, so I got the other one's next one's graphed.
Mhm.
There it is. Yay. Okay. And then we're now doing this one. So I'm gonna come down here, graph it. All right, so the domain of this, and I added in the horizontal asymptote and the vertical asymptote to help kind of see this. So the domain is everything except for this value here,
Yeah.
0. Okay, so your domain is minus infinity to 0, 0 comma infinity. If you want, I can actually move this picture down next to this. Maybe that would be even better.
Okay.
Maybe that'll be easier to see here. Okay, the range. So the range, like this thing goes down forever and it goes up forever, but it never is this horizontal value, which is 2.
Hmm.
So it's minus infinity to 2, 2 to infinity.
For the domain and range
Oh no.
with the asymptotes, do you put the union symbol or the and symbol?
So you're not supposed to use them. It's actually just a comma. Or I'm sorry, for domain. Did you say domain?
Yeah.
Okay, for domain, it's union. I'm sorry.
Okay.
These should be union. The instructor might actually care about that.
Got it. I just always mix them up.
Yeah, so the function is continuous everywhere except on its domain.
Hmm.
Okay, so everywhere on its domain. So you basically just reproducing its domain. Um,
Got it.
okay, so it's continuous from minus infinity to 0, union 0 comma infinity.
Hmm.
Basically the same thing as its domain. All right. So this one, we'll go with increasing first. Increasing. Increasing is when it's going up and to the right.
Okay.
So it's never actually going up and to the right. See how this goes down to the right, and then this goes down to the right. So it's actually never, like none. But it's decreasing on its domain. So it's minus infinity to 0, 0 comma infinity. So it's always decreasing because it's always going down to the right.
Mhm.
Bounds. So this one doesn't have any bounds because it goes up forever and down forever.
Yeah.
So I guess I would say none. It's got a place where it doesn't exist. The Extrema, it has no minimum because it goes down forever, and it has no maximum because it goes up forever.
Okay.
This one is symmetrical about this point right here, but there is no like symmetry about that point in general.
Okay.
Um,
So you would just say like
none.
symmetrical about the origin?
No, because it's not the origin. Like there is origin symmetry, but this one's moved up a little bit.
Oh. Oh, because the
Like
top.
it truly is, but they know that doesn't. It's not like a real symmetry.
Yeah, got it.
This one does have a vertical asymptote. We just mentioned it's x equals 0 and y equals 2.
Hmm.
All right, the end behavior. So as x goes to infinity, so that's as we go to the right, because that's what the graph goes. What is the y value that it approaches? Approaches this y value here.
2.
2, yeah. And as x goes to negative infinity, f of x, so that's going the other way. F of x also approaches 2.
Okay. And then you don't have to do the y.
That is y. I mean, that is what it is.
Oh. Oh, yeah.
There's only two. There's only x going to infinity and x going to negative infinity.
Got it.
All right, that's it for that one. So I can pull up the next SD, I think.
Yeah.
So we got SD 3 limits, like which problems? This is also out of scope for your class. I mentioned this
I
last time.
know. I'm just having a lot of trouble with it, and it keeps getting brought up in class. So we can just do it like a few of them. Let me pull it up. Okay. So just on page 1, there's the like additional practice, and then it says number 1.
Yes.
We could just do like the odds or something like that.
Okay. I'm not trying to be difficult or disagree with you. I'm really concerned that we're doing something that is just, I mean, this is what they're doing in calculus, which you're not in, and I'm
Yeah.
happy to do it. I will do it, but I'm just like, I don't know. Does your mom, is your mom aware of this? I mean, your mom is probably able to do something about this.
Yeah, I talked about it with her, but I mean, like my teacher's teaching it. There's a quiz on it soon, so I think I should just learn
Okay.
it.
All right. Okay, I'm doing part A here, and what I'm doing is I'm writing out what you need to read. The limit as x approaches 2 from the left.
Okay.
So like, and this may not mean much to you, but you have to use the one that's for left of 2, and this top one is for left of 2,
Mm-hmm.
and this bottom one is for right of 2. And again, like out of context, but the limit, the first thing you always do is just put that number in for x. So part A, like you have to, maybe you don't have to rewrite this, but you have to put 2 in for that.
Okay.
Okay, so it's 2 times 2 minus 3.
So it's 1.
Yes.
Um,
Okay, so for the second one, here, the second one here, it's the limit as x approaches 2 from the right, f of x. So you're essentially just doing the same thing. You're putting 2 into the other one. So it's 2 squared minus 1, which this is 3.
okay. And then what would I do for C?
Uh,
Wish
It's
I
the
didn't do
see
this.
that see this is where you got to know some calculus. If these are the same, which they're not, then you would say that the limit exists.
Oh yeah. And so all I have to say is like the limit does not exist.
Yes.
Got it.
All right. I just I'm losing my mind when I see stuff like this because I just don't know what to tell you. But yeah, we'll keep going here. We'll do number 3.
Yeah.
Um,
It's so confusing too. Like I've never done this before and it's
yeah.
getting thrown at me.
Well, this doesn't help you, but I was helping a Calculus 2 student earlier this week, and they didn't really do that well in Calculus 1, and it was just kind of the same thing as this. It's like they just were like, I don't understand, and I'm like, yeah, well, if you didn't understand it before, you're not going to understand it now. So, um, yeah, just way out of context. Okay, 3a. This is the limit as x goes to minus infinity. So minus infinity is right there. Okay.
Okay.
So it looks like it approaches 0. Like this basically approaches that value.
Uh-huh.
And then as you go to positive infinity on the right, it's the x value. It also approaches 0.
Yeah.
So it's because these aren't the same. So in the previous problem, it was 2 and 2, one from
Uh-huh.
the left, one from the right. The infinities are not the same. Like one is actually way out over here on the right, one is way out over here at the left. There is no conclusion, I guess. I guess the conclusion is it has a horizontal asymptote at y equals 0, but
Okay.
even that's a little bit odd. Okay, there's two-sided limits. Do we need to cover those?
Let's skip that. Let's just keep doing like the normal ones.
Is that everything then you want to do on SD3? Do you want me to go back and do question 2?
Um, let's just do SD4.
Okay.
It's just like function stuff, like just
Yeah,
review.
yeah. This is going to go a lot better because it's stuff you've seen before.
Yeah.
And okay. All right. Use the least common denominator to combine the fractions. Okay.
All right,
So
I can do this.
you can do the first one. The first one is 2 plus 3 over y, which is 5 over y.
Why?
Okay, great. And then this gets it gets more difficult here. So the next one, actually they're not numbered, but the next one is 2 plus 1 over x. 2
Okay.
has a denominator of 1. They need to have the same denominator, so you multiply the top and bottom by x. So it's 2x over x plus 1 over x. Is that clear? Is that
Yeah.
okay? So this becomes 2x plus 1 over x.
Okay.
All right. The next one, so that's your final answer on that. The next one is
Get rid of the X on the top.
no.
Okay.
That's like going backwards. You can't undo that. Yeah.
Okay.
Just leave it like that. The next one is is 1 over x plus 1 over y minus x over 1. So the LCD is xy.
Oh, okay.
It's 1xy, but you never write the 1. So you ask yourself, well, what am I missing? And I guess this is a good place for me to switch colors on this. Like the first one is missing a y.
Mm-hmm.
The second one is missing an x. And the third one on the bottom here, it's missing an x and a y and an x and a y. So you multiply by what it's missing.
Okay.
Do you recall doing that? Is that
Yeah, that makes sense.
okay? So this step, all I did is multiply the top,
Mm-hmm.
and then the bottom is always xy. Once you get the LCD, it's always in the bottom. So now you combine the numerator. X, I'm going to put X first, X plus Y minus X squared Y over XY.
And is that the final answer?
Yes, yes.
Okay.
All like these questions really could just say to combine until you have a common denominator, I guess.
Oh,
That'd be okay.
okay.
It's a little confusing the way it's written. Okay, now X over 3 plus X over 4. These do not have a common denominator. Your common denominator is 12.
Yeah.
So how do you get to 12? You multiply by 4 and by 4, by 3 and by 3. 4x up top, 3x up top, 12 and 12. Okay, so that becomes 7x over 12.
Got it.
Solutions to the equations. Okay. All right. So the next one, it says find the values of x that are solutions to the equations. Okay. So the first one follows from what we were just doing. Like you have to find a common denominator between 2, 6, and 3.
Mhm.
And it's better if you can use the smaller one, which is 6.
Yeah.
So you multiply by 3, nothing, because you already have 6, and then times 2 times 2. So that gets you 3x plus 1 equals 2x. And on the bottom, it's 6, 6, and 6. Make sure that's clear, because if it's not, we should redo that step.
I got it.
Okay. Now you can actually just set the numerator equal. The reason is because you multiply both sides by 6, the LCD, everything goes away. The shortcut is to just recognize that and write the numerator, and not even to write this step.
Yeah.
But that's the case here. So it's subtract 2x, subtract 2x, subtract 1, subtract 1, x equals -1.
Got it.
Not too bad here. All right, next one is the square root of 1 minus x squared plus 2 equals 3. You want to isolate the root.
Mm-hmm. So put 2 on the other side.
Yes, yes. Then you square both sides. So you square it. 1 minus x squared equals 1. And then you move things around. So you subtract 1, add x squared, and you get 0 equals x squared. So x equals 0. And surprised that the instructor gave you this, but that is the answer here.
Got it.
There is some extraneous solution stuff, but it didn't come into play on that one, so I'm not sure.
Oh, yeah. Okay.
So this one, you want to undo the cube, the 1/3 power. So you do that by cubing both sides,
Mm-hmm.
and that undoes it. And then you add 2 to get 10.
Yeah.
Okay, we are on to the next page. Just more solving. See, okay, like my perspective, what we're doing now is probably not difficult enough, and the stuff with limits was way too difficult. So,
Yeah.
but that's where we're at here. So this looks a little odd, but you end up just wanting to undo the 1/4 here. If you don't like that, I'm gonna write write this. If you don't like that, the alternative here is to clear the fraction by multiplying by the LCD. So like if you multiply everything by 12, you end up getting the same answer as over here, but maybe that's better. So 12 divided by 3 is 4x. 12 times a fourth is 3 equals 12.
Mm-hmm.
Subtract 3, you get 4x equals 9, x equals 9 over 4.
Okay.
Okay. That's probably the way you'll do it. Over here on
Yeah.
the left, you have to clear this. So you end up getting a fraction still. I mean, it doesn't like, it's not like you get something different, but you just have to. All right, so let's look at the next one. This one, you definitely want to clear the denominator first. I'm gonna snip this one in. So you multiply everything by 4 to do that. Left and right. On the left side, what you have to remember is you're multiplying both terms by 4. So in the
Okay.
first one, it just cancels. But I think the reason this is here is because some students only do it here and they don't do it to the next one, because it's 4 times 5 is 20.
Yeah.
Then you get 12x.
Okay.
All right, so subtract 2x, and you get 17 here equals 10x. And then divide both sides by 10. X equals 17 over 10, or 1.7.
Okay. Got it.
And we're up to the last one here. Are you noticing that you're getting less homework in this class, or is this just one
Yeah, I
assignment?
don't get a lot of homework. Like I don't have homework due tomorrow. So these are just like practice sheets we do in class that I just
Okay.
didn't understand. So I
So
knew
you're asking me, and I appreciate you doing that. I hopefully it's clear now. What is the LCD between 3, 4, and 2?
12.
12. So again, you can multiply left and right by 12. That's one option. Or you can just multiply to get the 12 in the bottom, like whichever way you prefer. And if that isn't clear, let me try to explain what I meant by that. The other option is to, let me change colors here, is since you want 12 in the bottom, is you multiply the top by 4 and the bottom by 4, the top by 3 and the bottom by 3, and then the top by 6 and the bottom by 6. Which do you see yourself
Oh.
doing? Because they're both correct.
Um, let's try the second way in blue. I
Let's
think
do that.
that'll be easier.
Okay. All right. So now the bottoms are all 12.
Mm-hmm.
Okay. So the top is 4 times t. Yeah. And the bottom is 3t plus 15 equals 6. And do you remember what I said in an earlier problem when we did this together?
Just like get rid of the 12.
Yes, you can just ignore them. 4t minus 4 plus 3t plus 15 equals 6.
Mm-hmm.
So these combine, that's 7t plus 11 equals 6. Subtract 11, 7t equals minus 5, t equals minus 5 over 7.
Okay.
That takes us to the end of the stuff that you sent me here. Is there more that you need to go over?
I
Does
know
this
it's
cover?
not on there, but could we just like run through completing this square?
Sure.
Okay.
All right, so let me give you some examples. Let's say I give you x squared plus 8x equals negative 15. Okay. So this is like kind of the trivial case, is we're trying to figure out the number that goes here.
Mhm.
and it's related to this number. So you have to take this number and you cut it in half. Okay. And then what goes here is that number squared. So what number is squared? What is that squared?
16.
16. But you have to put it in both positions.
Oh, yeah, okay.
So this equals 1. And then from this step here, and we'll do a few more of these, but from this step here, you're either solving or you're using the square root property. I'm sorry. I'm sorry. You solve by square root property, or you're trying to figure out what the vertex is of the parabola.
Okay.
If that doesn't make any sense, like you're probably doing one or the other, but for this. So let's do another one here. X squared minus 10x equals negative 15. Again, doesn't really matter. Okay. So the first thing, like, and sometimes this 15 is over here. I guess I should do an example like that. And then you just move it to the other side. Like you subtract 15, subtract 15. You have to create this gap here.
Uh-huh.
And so you have to figure out, well, what's half of this? Well, half of that is 5. So when you square 5,
It's 25.
it's 25. So plus 25 plus 25. So this equals 10.
Okay, so when you're completing the square, C is always gonna be positive, right?
No, because that, I mean, in this examples, so like here's what you just asked me. 8x, I don't know, minus 12 equals 0. Okay, so in this one, the answer is no, it's not, because there's a negative out in front.
How would you do that?
So first thing you do is you always move, like there's different ways to do this, and some instructors just give you the formula, but I don't think the formula is very helpful here. So it's minus x squared plus 8x equals 12.
Okay.
You factor out the negative. X squared minus 8x equals 12. So how do you complete the square here? Well, it's just like you did the previous problem. It's x minus 4 squared. It's half of that number.
Uh-huh.
So what goes here? This number squared, which is always positive. So that's plus 16, right? Do you
Yeah.
agree with that? But now you have to handle this negative. So when you factor this negative in, it becomes minus 16 up
Oh,
here.
okay.
Minus 16, minus 16.
So it's only positive or only negative if you like take the negative out and then put it back in.
Yes.
All right, got it.
Okay, so I mean, they can get more complicated. Minus 2x squared plus 20x, I don't know, minus 5.
Uh-huh.
Okay. So this is a new example. So the first thing you would do is move the 5 to the other side. You follow that?
Yeah.
So you'd add 5. So you get minus 2x squared plus 20x equals 5. This time you factor out a negative 2.
Mm-hmm.
So now when you're completing the square, the way I'm showing you, you always get down to, like, this is always positive because if you just factor it out. So this is plus 25. Do you see that?
Yeah.
But then see how the negative 2 goes to each of these. So what number goes here? It's negative 2 times.
Negative 50.
Yep. And you got a negative 50 on both sides. So as long as you like see the progression, they're kind of all the same.
Mm-hmm. Yeah, that makes sense.
Okay. So it could be like minus 3x squared minus 12x plus 20 equals 0. So what's the first thing to do?
Put the 20 on the other side.
Right. So it's minus 3x squared minus 12x equals minus 20. Now what do you do?
So you take Yeah, factor out the 3, and then half of -12 is -6.
Nope, nope, nope. You got to do it for both. You got to do it for both. That's
What?
what. Yeah. See how you factor -2 out of both of these,
Oh, yeah,
and
okay.
then factor -3 out of both of these.
Okay, so then it's 16 is C is 16.
Half of 4.
Half, oh, it's 4.
Yes.
Okay.
So you factor -3 out. See, when you multiply that in, you get back to the previous line.
Mhm.
That's the idea. I mean, that's the
Yeah, there's
that's
just a
the
lot of steps, but if that makes
yes.
sense now. I just completely forgot how to do it.
Okay, so this is +4, but then you have -3 here, so you -12, and
Uh-huh.
then you have to -12 here.
Okay,
Like these always have to match.
got it.
So it's that, and then this -3 is here. Actually, in the previous one, I didn't do that either. You have to bring this -2 down, and then there's a minus there. You get that in.
So the answer is that vertex form? Because
Yeah,
it's
if once you
right
move this back
here.
over, it is. Yeah,
Okay.
and that's why I said like it depends what you're trying to do. You might be asked to solve. You might be asked to just find the vertex.
Mm-hmm. So if I'm solving it, I'm factoring and then finding x.
If you're solving it, you're gonna like move this -3 over, square root both sides, and
Okay.
go down a few more steps.
Yeah,
Do you want to do another one, or do you feel like you got enough practice here?
I think I got it. Yeah, makes a lot more sense now.
All right. We have a little more time left if you would like, or we can end here. It's up to you.
Um, yeah, I think that's all I have for today.
Excellent. So I'll be able to send the notes and the screen recording out shortly. Thanks again for scheduling, and I'll see you next time.
All right, thanks, Matt. Bye-bye.
Bye.